Hey guys, I wanted to begin this video in which we are going to practice analyzing capacitor networks with a little bit of procedural discussion, meaning what is the order in which you ought to simplify circuit components. Now, if you feel like you already get this, then you can skip ahead to, probably about the minute-and-a-half mark. But if not, then listen up, because if you're combining circuit elements in the wrong order, then you're not going to be able to properly analyze the circuit. So this thing I keep seeing every now and then is sometimes people will combine C and E first, because they'll be looking at those and be like, oh yeah, see, those are in parallel, right? Those two there. Well, I agree in a sense. They are on separate branches of the circuit, but they're not simply in parallel. Okay? Simply in parallel would be if you had something going on like, this. Pardon the, oh geez, it's hard to draw on this thing. All right, that would be simply in parallel, okay? But since there's also capacitor D right here, and for that matter F and G, I can't just combine C and E as if they were simply in parallel. Rather, it's this branch is in parallel with this branch, and for that matter also in parallel with this branch. And so before I can combine C with E, I first have to combine C and D with each other. And then I have to combine E, F, and G with each other to turn it into this. Oh boy. Now I have to, this is not going to be a great drawing. To turn it into this. And then I can combine those three parallel branches with each other. All right, so just FYI, careful about the order in which you combine things. So for all three of the examples that we're going to do in this video, these are the two set of directions. Step 1, or part A, is find the equivalent capacitance, and part B is find the charge and voltage on each capacitor. This is in keeping with whatever I would ask you to do on a test or a quiz for exactly this kind of problem. Also, for recording your answers to all of these various practice problems, you should make, right at the outset, some kind of a table like this. It might not say A, B, C, D, E, F. It might have the numbers for the values of the capacitances. It depends how everything is labeled. But make a table like this to keep you organized. And here is practice problem number 1. Now, if you think you've got this, you're like, I totally know how to do this one. Pause the video, skip ahead a couple of minutes to the scene where I reveal all of the answers in one table, and there you go. Just look at the table and you'll know, hey, I know how to do this, and then proceed onwards to practice problem number 2. If you're not there and you want to take it, say, a few steps at a time, that's fine. Obviously, I'm going to walk through and explain this one, but definitely pause the video periodically, no matter who you are, and see if you can do whatever the next step is before I show it to you. Okay, so part A is find the equivalent capacitance. Pause me, find the equivalent capacitance. All right, now if you're trying to find the equivalent capacitance here, the first two that I would combine would be the 20 microfarad and the 16 microfarad. Okay, I will combine those two using my parallel equation down into 36. Because remember, the rule for parallel capacitors is their capacitances just add. So what that would turn into is this. Okay, so 12, 36, and 72 in series. All right, again, you should pause me and see if you can work out what that is. 8 microfarads. Success! All right, if not success, if you got 0.125, you forgot to flip it. Okay, so common mistake. But yeah, you always got to remember to flip it at the end, because it's 1 over the equivalent capacitance is 1 over C1 plus 1 over C2 plus 1 over C3. The next step, of course, is going to be finding the charge and voltage on each of the individual capacitors. So again, pause me, see if you know how to start it, look back over your notes, figure out what to do, and then resume and see if you're doing it right. Step 1, we got to find the charge on the equivalent capacitor, which, since it was 8 microfarads and it was hooked up to a 12-volt battery, is 96 microcoulombs. All right, now you got to figure out what to do with that 96 microcoulombs. So look back over your rules for series capacitors if you don't remember what to do next, and then see where it goes. All right, so pause me, do what you can, and then resume. That's right, series capacitors all receive the same charge as each other and as their equivalent capacitor. So now, plug in that 96 microcoulombs on each of those capacitors to figure out their potentials, or their voltages. And of course, pause me. And there we are, 8 volts, 2.67 volts, and 1.33 volts. Now, in terms of filling in your table, you should have filled in some values in your table already. And here's our table, and let's see, the values that we know right now would be, well, I'll fill in the ones we can be sure of. All right, there's some of them. I deliberately left out the 2.67 just for the sake of being able to talk about it. 2.67 is the potential on this equivalent capacitor right here. That one is equivalent to the 20 and the 16, which were in parallel. All right, so reviewing our parallel capacitors rules, remember parallel capacitors have the same volts as each other. So that's actually the next step in the problem, is we have to go up a level, and what we need to remember is that since that one, the 36 microfarad equivalent capacitor, has 2.67 volts on it, so do the 20 and the 16. All right, and so there we are. I'll explain this a little more maybe in the next slide. So this is what we knew so far about that 36 microfarad capacitor. It's storing 96 microcoulombs at 2.67 volts. But in fact, it is these two other individual capacitors. But since we know it's 2.67 volts across that capacitor, it's 2.67 volts on this one and on that one, either way we go around our circuit. Okay, so if it's 2.67 volts between here and there, it's 2.67 volts on both of those capacitors. All right, so that means we should be able to plug into Q equals C delta V and get our answers. So try that. All right, and now whatever that is. And there we have it, our fully filled in table, assuming that I didn't make any calculation mistakes. Sorry if I did. Okay, whatever. Forgive me, and move on to the next question. And also congratulations if you got all those right. Well done. Yep, next problem. All right, this one I decided to sort of keep it simple in terms of the diagram. All of these are going to be 60 microfarad capacitors, and I'm labeling them, A through G. And there's a 34-volt battery. Why 34? Because I wanted to make the numbers come out nice. Okay, that's all. All right, so same two steps, right? Part A, find the equivalent capacitance. Part B, start filling in the table. Again, skip ahead a few minutes if you feel like you know what you're doing. Or periodically pause if you feel like you need a little more of guided practice. Step 1, complete in simplification. Step 2. And the final answer for the equivalent capacitance, whatever that decimal is. All right, now we got to find the charge and voltage on each one. So remember, we, as usual, start at the end. Alright, there we go. The charge on the equivalent capacitor for the whole thing is 1,320 microcoulombs. Now go up the next layer. Pause me. Now it's time to go up a layer, all the way to the original circuit. Alright, time for the third and final practice problem. Hopefully by now you're kind of getting into a rhythm of it. I'm going to go through this sort of rapid fire, right? It'll be like how I did the last few slides where it'll just be, I'll show you an answer, pause for 3 seconds, move on, pause, okay? Alright, have at it. I hope that does it for you. Good luck on the quiz tomorrow. I'll see you on the internet.